All right. Good morning, everybody. You guys awake yet? I know it's still a little early. How many of you, this is your first session of the day? Second session. I'm very impressed. Very impressed. Well, I want to welcome you to Enriching Big Data for Analysis. My name is Adam Jorgensen. I'll tell you a little bit about what we're going to talk about today, just to make absolutely sure you guys all feel like you're still in the right room, because I would hate for you to sit through this whole thing and have it not be what you're looking for. So the goal of today's session is to make sure that we highlight the different areas that you're going to use the big data ecosystem for. So how many of you have heard of big data before? Kind of a buzzword now, right? Good. How many of you heard about it or learned a lot more about it this week in other sessions? Okay, good. So what we're going to try to do today is focus on major areas of big data as it would pertain to your particular organization. So we're going to talk about how we prepare that data, how we consume it, where it comes from, and really the goal for this being a 400-level session is we're going to gloss over things like, your users want a lot of data and some of those more, introductory concepts. So we're going to focus more on the individual technology pieces and how to sort of optimize those, how to make sure you're taking best practices with some of the different tools and things in the different ecosystems. So if that's what you're here for and you want to learn more about that, you're absolutely in the right place. If you're not, feel free to find a session that might be more better suited for what you're trying to get out of this time slot. I will not be, my feelings will absolutely not be hurt, I promise. So just a quick blurb about me. I've met some of you down by the booth. I see some friendly faces. My name is Adam Jorgensen. Like I mentioned, I'm the president of Pragmatic Works Consulting. We're a data platform partner of Microsoft's over in the US. We do a lot of work internationally as well. And our primary focus is all around helping folks do better things with their data. I'm lucky enough to be involved in the PASS organization, which is, again, another community organization that's largely focused on SQL Server and all of the SQL Server ecosystem. I've been doing this for a while, learned a lot of things. I've got a current focus on Azure and big data right now. If you guys have questions, we'll do that at the end, of course, but also if you have questions or follow-up, I want to make sure you have my contact info there on the slide. So, real quick, before we get started, I don't have a lot of jokes in the session, but I did have something funny happen to me while we were sightseeing the other day. And I was lucky enough to spend about an hour and go over to Plaza Mayor and walk around and see some of the street performers and, just get to meet a few people. And I was having a pretty good time until I ran into this guy. And he gave me a hard time. He wanted me to kind of take over for him for a little while so he could go on his lunch break, and I didn't think that was very nice, but I went ahead and let him take his picture with me, so we're in good shape. So today we're going to learn proven patterns for enriching and analyzing data with Microsoft services and technology. Well, what does that mean? That sounds a lot like marketing to me, to be honest with you. To me, that means we're going to take a look, like I said before, at each of those areas where you're going to find challenges and questions that might be solved by tools in the big data space. Maybe that's HD Insight, maybe it's Hive, maybe it's Pig, maybe it's Mahout, maybe it's just Hadoop and HDFS. There could be any combination of those different things that you're going to be able to use to solve some problems. And of course, the focus of a big data solution, as I'm sure many of you learned this week, is to be able to continue to ask better questions, right? It's sort of the next step, I believe, beyond sort of regular business intelligence, right? It gives us the ability to process more data, volume, variety, and velocity. I'm sure you've heard those terms this week. I think it's a good way to sort of break that down. And so I have this concept, and unfortunately, my co-presenter and co-creator of this session that presented with me in North America couldn't make it, but this is a great way that she normally uses to explain this concept, and I really like it. And she says, look, a lot of organizations have this, she calls it goo, stuff that's floating around their organization, right? Different information, access, flat files, 16 different systems that all, struggle to interconnect. And I think we spend a lot of time trying to bring that data together and do it in a way that creates a tabular relational structure. And a lot of times we're doing that just to run a few queries or to be able to do something that we do once a year or once a quarter, or something that's more transient, right? Something that we don't really need to keep around. But the data is important because we may, 6 months from now, find out that we need to ask a better question or be able to ask better questions overall. And so a lot of you have seen those types of sales pitches sort of for big data, right, this week and before. Leave your data around, keep it where it's at, work with the data where it's originated and all those types of things. What we're going to talk about today is how we optimize each phase of that process. And so the 3 phases we're going to focus on are data consumption, data refinement, and data acquisition. So obviously, we have to go get the data from somewhere. So we're going to talk about, how do we get it, right? And how do we get it up into our big data environment? And how do we optimize that? So we're not going to be doing, build your first SSIS package against Hadoop. We're not going to be doing any of that. We're going to talk about the Azure Blob Store. We're going to talk about how we optimize working with Azure Storage and how some of the Azure Storage works under the covers to be able to acquire, retain, and optimize the storage and management of that data. Then we're going to talk about data refinement. Now that we've got it up there in our Blob Store, it's in the cloud. The cloud solves everything, right? You guys probably heard that this week. But you have to know how to use it, right? So we have to be able to do things with our data and with our information that's in the cloud. The elasticity and flexibility of the cloud gives us some really great opportunities. And we're going to talk about Hive in particular and how we optimize Hive, especially to be able to run and do some of the things that we want to do. Last, we're going to talk about data consumption. There's some great patterns that exist today, and there's a lot of great things that are coming. And so we're going to talk a little bit about what's here, what you can go back to your office Monday and actually do, hands-on, and then what's coming in the future. So I was really lucky to spend a little bit of time with the team here this week and even get some new updated information to get in the slides for you. I will make one caveat. If you have gone out and downloaded the slides from the portal, these are updated slides as of yesterday, so they will not match exactly. I will make sure they get updated in the portal. So give it about 2 to 3 days for Microsoft to get it pushed through and updated, and you can get them. I also have a bunch of my speaker notes with links and things in the slides for you guys for reference, because I know a lot of people like those. So the first thing we want to talk about real quick is just a quick overview of HD Insight Service. I'm sure you guys have seen the portal. I'm not going to log in and say this is the portal. We're not going to do that. Keep you guys entertained a little bit this morning. Hadoop has a lot of different components. So how many of you guys have seen or heard of Hadoop before this week? Okay, good. Awesome. You guys are way better than North America. I did this in North America and like 4 hands went up, so you guys are way ahead. There's obviously a lot of components and tools that go into this ecosystem, and there's more than are even on this slide. And HD Insight doesn't have all of these yet, but it has all of the core ones. We've got HDFS, we've got MapReduce, Pig, Hive, HCatalog. We've got support for NoSQL databases through Azure IaaS. We can do some really cool things there. And then all the way to your right, we've got all of our data consumption. So we've got data integration, data explorer, and then of course the entire Microsoft BI stack that we can leverage. But like I said, we're going to start off talking about data acquisition as how we get data up into the Azure environment, right? So we're going to try to talk, especially with HD Insight, we're going to use the Azure storage. We want to use Azure Blob Storage. You'll hear the term ASV a lot, Azure Storage Vault. And a lot of folks say, well, that's Azure Storage. It's not really. And sometimes the terminology can be a little confusing, so I'm going to clear it up for you this morning. ASV is essentially nothing more than a communication protocol that allows Azure Blob Storage to look and act just like HDFS to HD Insight service. So it takes Azure Blob Store and makes it look and act like HDFS so that commands will respond in a similar way, that we can do put operations and all the types of things that you can do in HDFS, we can do to Azure Blob Storage through HD Insight because of this ASV layer. We leverage the Azure Flat Network Storage largely because it's so fast. So there's been huge improvements to this storage over the last year and a half. We'll talk about some of the specs and some of the throughput and things like that as we go forward, but the speed really comes from this new flat storage network topology that's been put in. There's an aggregate backplane per data center of a little bit above 50 terabytes a second. That's pretty fast. I don't think I need to move anything faster than that. So from a speed and scalability perspective, that's all been thought in and baked in to the service. So being able to leverage the Azure Storage Vault and the Azure Blob Storage as the primary storage for HD Insight gives us all the benefits of HDFS from a distributed file store perspective, but it also gives us the benefits of separating storage from compute by being able to persist our data even when our cluster's not there. We'll talk about that a little bit in a second. So a lot of people say, well, that's going to use so much network bandwidth. Well, it's going to use a little bit, no question. But the basic process that we're going to undertake is we're going to stream data from the blob store into our compute nodes. We're going to run our map process. That's going to run locally on our individual nodes. We're going to run our sort. That's pretty much going to run locally. The shuffle is going to go back and forth a little bit, moving some data around as it begins to reduce and aggregate. And then the reduce is going to push data back out to the storage for whatever our output is, but it's going to be a much, much smaller amount of data. So really, the only time we're taking a big hit from a network perspective is on the map phase. Hadoop, if you remember, if you've seen this before, does not like a lot of little tiny files because there's a concept called a name node in Hadoop. That name node has to manage all of those individual files and where they're located. So if you have hundreds of thousands and millions of individual tiny little files, your performance is not going to be as good as if you have a lower number of files that are larger in size. It's actually easier for Hadoop to keep track of that, manage it, and run through those files. That was a little different to me when I first heard that. We've done testing. It's a pretty well proven pattern. So just kind of keep that in mind as you're loading HDFS and building maybe out your first prototype or your first proof of concept. The biggest reason for me that I like using the Azure storage, and I like the fact that it's paired with HD Insight, there's really two reasons. One is the data durability. So if you have local HDFS, you really have no data durability or SLA around keeping your data. I mean, if the nodes go down, if those types of things happen, you're going to lose your data. Azure storage is locally replicated, geo-replicated, and it's got all sorts of SLAs and guarantees around data availability. The other big reason is when I shut my cluster off, I still have access to my data. So if I have multiple teams in my organization that want to work with that data, or if I have different clusters for different types of analysis or different schedules or any of those types of things, I've got the flexibility to reuse that data. If I can reuse my data, now I'm saving money on storage because I don't know about you, but I'm sure some of your organizations have multiple copies of the same data laying around because people have to use it different ways. Most organizations do. This can really help with that because you can store it up in one container in Azure, and a lot of folks can then reuse it as long as they have access to the container. So a couple points about using Azure storage with HD Insight. We get very good command line support. So there's a couple of functions like fs check, file system check. A couple of the DFS commands don't work quite the same. But 98 to 99% of your functionality really is going to be very compatible from a command line perspective. And again, we get that because we have that ASV layer that allows allows Azure storage to look like HDFS to HD Insight. I've got a URI, an example access URI, if you're wondering how you connect to it. It's very simple. It's ASV, ASVS for secure. You always want to make sure it's not required to put the container name, the fully qualified name in there if you want to connect to the default container. I generally recommend it because otherwise you'll accidentally connect to your default container and then you might be loading data or putting things somewhere. I'm sort of a details kind of guy, so I like to make sure that things are very well spelled out. And then it's just your add account name .blob.core.windows.net, and then whatever path you want to put it out to. The thing I like about that is it's very programmatic, so we can automate it very easily. We've got PowerShell that we can work with. We've got all sorts of tools and capabilities to be able to interact with getting this data up into Azure Storage. And we'll talk about some of those tools here in just a second in a little bit more detail. We've also got a number of file systems that are available to HD Insight. Of course, your default file system, your default containers, any other public file systems or containers up in Azure Storage. So if you have organizations that give you public data, government data, anything like that that you can subscribe to. There's a lot of those out there now, and that's growing. That's a great option. Even other private data. So if your finance department has data, or if your sales department has data that they've made available, all you need is the access key that you can control internally, and you can have access to that data right from your cluster. Very, very straightforward. The important thing to remember is most of your commands are going to work very, very well. Things like ls, copy from local, all of the traditional Hadoop commands that you're used to using are going to function very, very well. The only little trick here is if you're going to provide additional access to an additional file system or account, once you change the property in this core site XML file and your cluster drops, you're going to lose that change. So I know that's kind of a thumbs down, right? Because you're going to have to go back in and change it. One of the things I will say is there are improvements to that coming. So I wouldn't let that be a hang-up for you for very long. So we've talked a little bit about storage. Now let's talk about how we go get the data. So data movement to the cloud is actually pretty straightforward. Plus it's free, which is really nice. I like free. So some perks or some benefits of using Windows Azure Blob Storage. Of course, we talked about the data reuse. We get cluster independence, so we've separated the storage from the compute. So multiple clusters, multiple types of analysis, multiple companies and teams can all use the same sets of data without having to make duplicate copies. We've got a lower cost, traditionally, to store larger volumes of data. Plus, we've got the scalability of geo-replication. We've got elastic scale of storage. So if you decide tomorrow that you need another terabyte of storage, how many of you have ever had to go ask the storage team for more storage? It can be a challenge, right? And it's not their fault. They're not trying to be mean, most of them. They have to plan just like everybody else. And so with a technology like this, it gives us the ability to be flexible, use what we need, and then peel it back when we don't need it necessarily and recoup that cost so we're not stuck with the new half a rack of storage or disk that we just ordered. A few scale tips, we mentioned a couple already. Fewer larger files, definitely better than many small files. Very, very important. Also, in your particular instance, different file formats may make a difference as you're doing processing. Avro, CSV, zip, we'll talk about some of those different things in a few minutes. But test out some different file formats, different layouts, to really understand what's going to work best for your particular type of analysis. You can also leverage multiple storage accounts to get concurrent loading. So a lot of people have said, well, I'm pushing as fast as I can, especially some of the larger customers. We're pushing as fast as we can over one storage account, and it's still taking 45 minutes, and I need it to load in 7 minutes. There's a way to do that. We just need to parallel load for multiple storage accounts. Not a problem. We can make that happen. So the first thing we want to think about when we're moving data to the cloud is obviously we do pay for storage. So even though it is lower cost, we're still going to pay for it. So we want to look at compressing our files. It's going to save us generally about 80 to 90% on space, depending, of course, on your type of files. But usually we're talking about flat files, XML, existing compressed files. The only time you won't get that much space is if you're using binary files, potentially like images, video files, if you're doing any kind of sort of media work or things like that. Depending on the compression of the media, you may or may not get quite as much compression. HD Insight supports gzip, BZ2, Hive's deflate, as well as you're going to reduce your disk I/O and network traffic. So obviously, if we're trying to load data and acquire it up into the cloud as quickly as possible, the less we have to move, the better. So if we can compress it on the way in, the other nice thing is many of the tools in the Hadoop ecosystem can read compressed files. So if you have a zip file or a BZ2 file or something like that up in the cloud, we don't necessarily have to unpack that and store it somewhere. We can just read directly into that compressed file, which I think is very cool. Of course, it's going to cost less for direct storage costs. By the way, on a number of the slides, you'll see links at the bottom for a white paper or an article or something. I tried to include these for you just as a reference for if you want to read more about these particular areas or subject matters, largely because they go into a lot of detail on what they've tested and what they've seen, so you can compare it to your specific use cases and try to get a good understanding of which areas will give you the best benefit. So when we actually go to move our files, how are we going to do that? Well, there's a few ways. We've got a tool called AZ Copy. AZ Copy is, how many of you have ever seen RoboCopy before? You're all fully qualified to use AZ Copy. It's basically the same thing. It's command line. The only difference is your destination is going to be that Azure Storage Vault URI that we had on the other slide. Very, very straightforward. It's pretty fast. Works multi-threaded, and you can run multiple instances at a time, just like RoboCopy. Just like RoboCopy. Now, if you're just doing more exploratory, moving one and two files at a time, that type of thing, if you're looking for more of a browsing type of experience, Azure Cloud Explorer is up on CodePlex. There's also 3 or 4 other companies that make, for cost tools. Cloudberry is only about $40 US though, so it's relatively inexpensive. Aspera and Etunity Cloud Beam are more enterprise-focused options there for moving your data up to the cloud. We've also got SSIS. We've got the portal UI if you just need to upload a few files, or if you need to give your users the capability to easily upload a few files, you can put them in there. And then, of course, we have our Hadoop command line interface. So getting the data up to the cloud is generally not an issue. There's a number of ways that we can explore that and make that happen. The trick is finding those best practices for getting it up there appropriately. So where are we going to store it? Azure Blob Store. How are we going to access that? Well, through ASV. That gives us the translation layer. How are we going to make sure that the information is as efficient as possible? We're going to compress it and make sure that we're only storing what we need to store, giving us the opportunity to store all of that big data that we want to make sure that our end users ultimately will have access to. I left this in here as an example of ASV. I'm sure some of you guys in the back might not be able to see that as well, so I apologize. But we're basically just saying AZ copy, C:/flights, and then we're saying copy it out to our storage name and our destination key. Very straightforward. I left them as a template, so you can literally copy and paste that into Notepad or your text editor, fill in your information, and you should be good to go. So now we've got our data up in Azure Storage. Let's talk about how we go about refining it. So there's a lot of different online demos, and we'll talk about some of the resources that you have access to freely available through MSDN and through TechNet and through Microsoft's public website. We'll talk about those toward the end, and I have slides at the end as well that we won't cover. They're in an appendix that give you links to all of that information, so you can go check it out. But this is a pretty typical, I'll use my quotes, pretty typical sort of solution or pattern that we run into in the big data world, right? So we have some files that we've zipped up in our Azure Blob Store. Those are being consumed by our HD Insight service, and then we need to do more with it, right? So it's kind of great that it's in HD Insight and maybe it's in a Hive table, but how do we turn that into something that our end users can really be excited about? So right now, where do they get their data from? Maybe a data warehouse or a data mart or reports that come from those environments. Very, very important. So we have capabilities to do all those same types of things. What do end users want to be able to use? Excel, right? Ultimately, even if you give them a report, I read a survey about 6 months ago or so that said ultimately 95% of all reports that are ever run in the world ultimately end up in Excel. So why don't we just start there? It seems like a lot of extra processing to redo it all 95% of the time. So we'll talk about here in just a minute how we get the data in and out, how we leverage analysis services, how we leverage Excel and Data Explorer to skip the whole BI stack and go straight to HD Insight and HDFS up in Azure. We'll also talk in just a second about Hive and how we leverage that, because it's really going to be the foundation for a lot of that technology. So really quick, a couple of things. I'm sure most of you raised your hands, so you're very Hadoop savvy people. But we're going to do data preparation typically with either Hive or Pig. If we're doing it in Hadoop, most of you are going to be starting or working in Hive or Pig. So Hive is traditionally used to create some sort of structure over files. So you've heard this data referred to as unstructured data. I hate that term, to be honest, because almost all data has some structure, right? I had somebody the other day tell me that JSON data or Twitter data was not structured, and I said, no, it's very structured. It's just not tabular, right? So it doesn't very nice and neatly fit into a table. And what Hive gives us the ability to do is process and refine data that may be in that JSON format, or may be in XML, or may be in more of a straight delimited file with no headers and those types of things. And it allows us to put a more relational type structure over top of it, so that our tools can consume it easier, our end users can understand it a little bit better, without having to go through a complicated ETL process and data cleansing exercise. Of course, you can do that if you need to, but a lot of customers need to be able to get the data to this form, explore it, understand it, and then maybe there's a piece of it that you'll pull out and take through that end-to-end sort of enterprise BI process, if you want to think of it that way. Hive, of course, generates and runs MapReduce under the covers. It abstracts the ability or the requirement for you to know how to write MapReduce in Java or .NET, and just lets you write HQL or Hive QL queries. I'm sure many of you have seen that and heard that before, especially if you were here this week and saw those sessions. Pig is generally referred to as a data flow scripting language. So how many of you have used SSIS before? Okay, so the best way for me to explain Pig, if you haven't seen it or if you haven't used it, is if you were to take your SSIS package and put it on one half of your screen, and take Notepad and put it on your other half, and every line in Notepad, you just wrote one sentence about what each component in your SSIS package was doing. Load data from file. Aggregate data on country. Filter out where country is not Spain. All of those types of things that you're doing as you move through your SSIS package. Output data to flat file. Move flat file to FTP site. All of those types of things. Pig is very much like that. It's a line-by-line sort of declarative data flow scripting language. Very powerful. Again, abstracting the requirement to run MapReduce. Most of you are going to spend a lot of time working with Hive, probably before you get to Pig. It's what we've been seeing. I apologize if some of you really wanted to get a lot out of Pig today. We're going to focus mostly on Hive. The important thing here with the Hive architecture is that there's a lot to it. It's actually pretty powerful. And it's continuing to get better and better between Microsoft's collaboration with the open source community. Obviously, we want to be able to bring things like column store performance and additional security and integration and all those types of things that Microsoft's really known for. And then the things that the open source community is known for with rapid time to market and innovation and new features and those types of things. I think this is going to continue to be a space that grows and evolves very, very well. But you'll see at the very bottom, we've got, of course, a compiler, an optimizer, an executor. That's what's actually really working with the code and running it, generating that MapReduce, and executing it on your Hadoop cluster. Above that, we've got support for ODBC, JDBC. There's a web interface, command line interface. There's a metastore, of course, that's, if you're familiar with HCatalog, you probably know what that is. And then, of course, Hive QL, which is our language that we can use. It's very, very close to almost any other SQL language that you've used in the past. So I had never seen it before when I started using it. I only ran into a couple little things that were very different. The nice thing is, for any of these little languages that we're talking about, Hive QL, Pig, any of those, if you go out to Apache's website, they've got language references right there for you. Very, very straightforward and very easy to understand. And there's a link to that in one of the slides at the end of the deck. So how do we go about doing data preparation with Hive? Well, there's a few ways. So one, we can create an external table or an internal table. External tables are really good when you want your data used outside of Hive. So you've got all this data, other people are using it, you just need to reference it as a table to be able to do something with it. That's very important. You can also use external tables, and this is my favorite use for them, because working in business intelligence and data warehousing for so long, the big thing that everybody wants is sort of real-time BI, right? Real-time reporting. I've heard every version of real-time reporting you can possibly imagine. This allows you to have your data updatable in real time. So as you load those files onto the file system, think of an external table like a view. So how many of you know what a view is in SQL Server? Right. So a view doesn't change, it just pulls data from the table as the data in the table changes, right? Very similar thing here. Files get updated, et cetera, et cetera. Now, the important thing to remember about Hive is just like MapReduce, it's not for those ultra low latency queries. So you're generally not going to hit run and get your answer back just like that, like you would in a relational database. It's batch. That's the important thing to remember about big data and Hadoop, is until they continue to refine some of these newer initiatives that are improving on some of that performance for certain types of queries, most of these operations are considered batch, and they will generally take longer than on a relational database. But again, they're designed to be used on data that's not great for a relational database. So they're two very different use cases. The other thing is, if you still need your data when you drop the table, make sure it's an external table. Otherwise, your data, you can wave bye to it. It's going to go away. Anytime Hive should not own the data or control settings or directories or anything like that, anytime you're just using it to surface the data to be able to query it, external tables are great for that. But internal tables have their use as well. When the data is transient, short-term usage, you can create the table based on an existing table. So you can do a create as select, which gives you some additional flexibility. So if you have a much larger table and your end users really just need a very small subset to work with for a little bit, you don't have to go through partitioning and all these other things, which we'll talk about in a minute. You can just create the table as a select from another table and do a subset and do some of those types of things. At that point, when you drop the table or do any type of cleanup activity, that copy of the data is going to go away. So that's the important thing to remember. Perfect. So I'm going to talk about partitioning for just a minute, and then I'm going to tell you why doing it this way is not a good idea. So I have included the not good idea, and then the next slide is the much better idea. So we'll talk about that in a little more detail. Partitioning is a great thing. It gives us a lot of benefits. We get range elimination. We get the ability to handle compression. We get lots of flexibility when we can partition our tables in Hive. It's usually very straightforward. How many of you have partitioned tables in a database before? You're more than qualified to do this, I promise you. There's less options. It's much more straightforward. You're going to do the same kinds of things you're going to do when you create your table, the same statement. But if you'll notice, I've highlighted in red the differences. So we're just going to add a partitioned by, and we'll say partitioned by year, because that makes sense. And then at the bottom, you'll notice I have alter table statements for flights, and we're adding partitions for year 10, year 11, year 12, year 13. Does anybody know what the problem with that is? I have to create all of those. I'm a busy guy. I can't log in every 5 days and add a new partition to my table. I'll forget. And when I forget, that's going to break. And then I'm going to get a phone call that reminds me that I forgot. And that's going to be a problem. So there's a better way to do this. And I told you I would show you the better way, so I will. The better way is to do what we like to call dynamic partitioning. And this is a much better approach in most cases. Dynamic partitioning, you'll notice the lack of red. This is much simpler. You're going to be able to come in, and of course you'll notice at the top I have my statement level compression. So I'm saying we're going to compress the output, which is going to take all those internal tables that get created as part of my MapReduce processing, and make sure those are also compressed. Very, very good thing to do. It's going to make the data that moves across those nodes in those shuffle operations much more efficient, much faster. We also are going to compress our output. So as the output comes back up through the reducers, that's going to be compressed. We're also going to make sure that we're using the right compression codec. Now, if you're a media company, we have a couple of clients that are heavy voice and media companies. They work a lot with voice and video files. They have written their own compression codecs, and so they use those. How many of you have your own compression codec? Yeah, me neither. So just use the default. It works pretty well. Now, those are not requirements to do dynamic partitioning. It's just a good idea to do it at the statement level. Because you may not want to do it for every single statement. You can set properties in your core site XML file and a couple of other places to do that across the cluster. The only challenge is, just like the other property I mentioned, when you drop your cluster, what's going to happen? It goes away. So if you're used to putting it in your statements, that's a good idea. Now, dynamic partitioning. We're going to do something very, very complicated, and we're going to say set hive exec dynamic partition equals true. That's really about it. Then we're going to come in and we're going to say insert overwrite table, whatever our table name is, and we're going to partition it, and we're just going to give it the column names. And we're not going to do anything else. And then as the data gets loaded, it's going to automatically put it into the proper partitions and where those buckets are supposed to be. Now, what's great about that is if I'm partitioned by customer, I don't have to go back in and add partitions every time we add a customer, or a year, or a calendar change, or any of those types of things. Now, the only trick to this is if you're doing a lot of partitions, and I mean for any particular table up above, tens of thousands or 100,000 in the entire cluster, you're going to need to go in and make some edits to a few properties because there are some default limits. It's 10,000 partitions is the default per table as far as dynamic partitioning. That's going to work for most of you. For some of you that have partitions that are a little bit more granular than that, or you're partitioned and you're going to need more partitions than that, the only thing I would caution you about is you may want to rethink what you're partitioned on. Largely because it's going to be a lot of processing to go through all those partitions. And if you don't need all of those, try to avoid them. However, if you do, and there are some great use cases for when you might need them, you just have to go in and edit a few properties. I put some notes, the nitty-gritty sort of details, in the deck for you in the notes section. So if you guys need to find those properties, I have descriptions and a link out to the Apache source document that'll tell you exactly what to change them to and what the parameters are, and those types of things. So you can have that as a reference as soon as the deck gets updated. So there's a few Hive best practices that we want to talk about. Some of these we've already mentioned, so I'll skip over those. The order of tables in your query and the columns in your query can affect performance pretty significantly. And it has to do with the type of join that's going to be generated under the covers in MapReduce. We want to try to maximize getting a map join, which is going to be the best for joining our large tables. Typically, you're also going to want to make sure your largest table is the last one in your query. Your indexes can help. So you can create indexes, of course, in Hive. They might help, but they're not updatable. And so when you want to recreate the index or update the table, you have to drop and recreate your index, which does add some overhead. Of course, you want to make sure you compress your files where possible. Make sure that your user tools, however, will read compressed files. One of the things we'll talk about in a minute. How many of you saw Data Explorer this week? Good. How many of you think that's a pretty cool tool? Yeah, good. I would agree. And it can connect to anything. I mean, really, I've yet to run into something it can't connect to, except for one thing: compressed files. So if you are going to use Data Explorer, we either need to make sure, and we'll talk about this in a little bit when we talk about consumption, But we need to make sure that we know which of our tools will hit directly and read those compressed files, or which ones we need to create an external table in Hive and go connect that way. So just be cognizant of that. A few operations. Of course, we support text files, sequence files, RCI files, and Avro. I put a link in there to a really informative blog by a guy named Carl Nolan, who writes a lot of really good things on using XML in Hadoop, and particularly on this blog in HD Insight. There's no magic bullet to processing XML. XML has its challenges, as many of you who've worked with it understand, but there are some good patterns in that article that he goes into more detail on if that's a particular use case that you have. Make sure we remove headers before we load. Partition for loading. So if you do have a lot of partitions, that whole parallel storage account loading pattern might make sense for you. It just depends on what your individual situation really is. The other thing, we have a small file size property in our configuration file. Sometimes you will run a query against a file or against a table, and if the table is small enough, it'll put the whole thing into memory and run out of memory. What I have run into is a lot of folks say, my files are very small, but they're not running into memory. And I say, well, how small are they? They're like 27 megabytes. Well, the default limit is 25. So anything under 25, you're good. Most of the clients that I have working with this, they have enough memory to fit more than 25 megabytes into memory at a time. So they up that file size to maybe half a gig to a gig, depending upon how many concurrent operations they're running at one time. And that's definitely going to be a trial and error experiment type of thing. But it's a great way to boost performance the more of those intermediate files you can get to stay in memory at one time. So once we made sure we put some best practices in, now we can do some tuning. Tuning is fun, because when people say it's too slow, you get to do some magic back in your office, and then you go back out and they go, oh, what did you do? And they're very surprised, and they're amazed at how smart you are. The important thing is to know before you go. So a lot of times, you'll be introduced to an environment. Some of you may not get the opportunity to build the environment yourself. You may be working in somebody else's environment. So having a good understanding of these best practices is really very important to be able to make sure that you can check and make sure that they're using some of those best practices, right? I don't know how many of you have ever spent time tuning a query or a database or any type of application only to realize that there was some underlying best practice being broken. Make sure that you understand these before you go in. Know your join types. We've got skew joins, common joins, map joins. There's 3 or 4 join types. Most of them have very specific use cases. And again, I've got more details on all of those individual join types in the notes of the deck, so you guys can read through those. The map join is the most important. That's the one you're really looking to try to leverage if you're using large tables. If you're using small tables, generally you're not going to run into performance challenges. The skew join in particular is important because you may want to tell MapReduce that you know in advance that your data is skewed, that you know in advance that 75% of your data is going to come from these 3 partitions. So we want to assign and reallocate how some of those maps and reducers are being allocated and placed. And we can do that. We've got the flexibility to do that. Make sure that you understand how to use the explain statement. How many of you have ever looked at a query plan in a database? It's informative, right? Especially if you're trying to figure out exactly what it's doing. We can do something very similar here. The trick is you have to put the word explain in front of the last query of your batch. It's pretty straightforward. Again, it's pretty well documented. But if you're not having trouble seeing exactly what your query is doing, that's a great way to generate that plan and be able to see more detail. It'll generate an abstract syntax tree that's more detailed than the example I have there, and you'll actually be able to sort of step through and see what's happening. Be careful with the limit statement. I have a lot of people who do a lot of testing, and they say, well, I only need the first 100 rows. So they'll say select star from my table, limit 100. There's a problem with that. Does anybody know what the problem is? It only limits the data that comes back to the client. it still runs the entire query on your cluster. So you're not actually saving any processing time, any horsepower, anything really, other than just a little bit of client rendering time. And chances are the client's going to cut off the row set at some point anyway. So just be careful when you're using limit. There's other ways to restrict your queries. We learned about a couple. One of them is partitioning. That's a big one. Do I expect that to improve over time? Absolutely. But it's definitely something that as you start writing more and more queries, you want to be aware of. Watch out for bottlenecks between your maps and your reducers. If you're seeing a lot of map activity and not a lot of reduce activity, and it seems to be taking a lot of time in your reduce phase, you may need to go into your properties and adjust the number of reducers. You can adjust that up. That's not a problem. Feel free. My suggestion is, especially when you go through these exercises, just make copies of your config files and make all kinds of changes to them. Have fun with it, right? Just try to run the biggest thing you can and see where the bottleneck is. Try to create some of those issues that you're going to see in a real-world environment. And you'll very quickly begin to see, oh, when this happens, I get this, and it's very specific. And you'll remember that. Being able to do that and test and experiment is really important. Then you can put all your default config files back, and you'll be in good shape. So the last section of things we're going to talk about is data consumption. Data consumption is largely focused on, now you guys have done a great job of acquiring your data. We've sort of prepared it. We've refined it. We've got it into these, nicely tuned files and Hive tables, and we've, got everything laid out and organized the way that we want. So now we're going to go up to the top layer. And you guys have seen enough demos of Data Explorer and all those types of things, and there's a million of them on videos, so I'm not going to do a 45-minute demo of Data Explorer for you. I'm sure you appreciate that. What I am going to do is go through patterns as far as how we leverage each of those tools, how we connect, and how we make sure that each one of those tools is working in the proper use case for when you're supposed to be using it. So Data Explorer's first. You guys have seen a lot about Data Explorer this week already, so I won't spend too much time on it. But there's a couple things that you want to know. So they've showed you the shiny demos, right? You guys saw all those. And they look great, don't they? Pretty good. There's a couple things, and I don't want this to decrease your enthusiasm for Data Explorer at all, because it's going to give you a lot of really great functionality. What I want to make sure you're aware of are a few little things that you'll run into as you use Data Explorer to really begin doing analysis, especially when it comes to leveraging HD Insight or your Hadoop environment. It's very well suited for self-service data that fits in Excel. I think we already knew that. It's designed for data-driven shaping, sort of design while you drive, bring data in, bring other data in, go through it, filter it out, all the things that they showed you in the demo. It's really good for sampling data. Take care with the size of data that you're bringing in. We're not going to bring in 1 million rows in a Data Explorer, right? I hope in one of the sessions they told you that it's only bringing in a sample. And depending upon the size of the data, really the width of the data, it's only going to bring in between 5,000 and 7,000 rows, approximately, give or take. Now, all of the things that you do to that data will then, of course, be pushed out and processed. But it's important to remember that there's no governor to prevent users from pulling too much data. So they can go in and say, I want 1 billion rows. And that's not going to work. I think we know that's not going to work. But if they say 150,000, that will probably finish. And if they're doing that every 15 minutes trying to experiment and play around, just be aware of that. Now, is Data Explorer continuing to improve? Oh, all the time. I mean, even just through the beta, they've added so much functionality. So I expect this experience to continue to get better and better and better, and I know there's a lot of investment going in there. The only thing I will say is it pretty much reads everything, except binary files, and like we talked about a moment ago, compressed files. So if you have compressed files and you need to be able to work with them with Data Explorer, your best bet is going to be to either take the files from particular partitions that you know you need to work with and uncompress them, which is not a bad option, or create a Hive table and partition it over those partitions and just query the Hive table. So there's a number of options that you can leverage as we go through that. Now, the first question, well, not the first question, maybe the second question I get after we explain a lot of these things to customers. So what is big data and how will you use it and does it make sense for you and are you seeing these types of challenges? The big question is, how do I secure it? The security story in Hadoop is, we'll call it not so good. How do I put any governance on it? How do I make sure that this manager can't see this manager's data and that my employees can't see each other's human resources files and any of those types of things that may be exposed? How do we do that? Well, we do it by using the rest of the Microsoft BI stack. Once that data is stored and refined, now we can consume it just like we consume every other data source. We can bring it into analysis services, multidimensional, tabular. We can use Data Explorer, Excel, Power Pivot, all of those tools that are out there and available. And the governance and security is pretty well baked in there. Those are also tools that your IT department, your development organizations, at least some of those tools are probably very familiar to them. From a deployment, from a patching, security, management, user training, support, all of those areas, very, very straightforward because these tools have been around now. They've continued to improve, and they really are very class leading. We can put data quality, data cleansing over top of it with all of our DQS and master data tools. We've got scalability even beyond Hadoop because we've got analysis services, we've got multidimensional and tabular and all these additional pieces of functionality. And then, of course, we can put security, governance, and compliance in place. Those are the three biggest areas that right now the Hadoop ecosystem on its own struggles with, being candid. It doesn't have great solutions for these yet. And so the best pattern is to go through your data acquisition and your data refinement and then leverage all these tools that you already have and that you're already good at and bring that information back to your end users or integrate the information that you need out of your Hadoop ecosystem right over into your enterprise BI environment. So with that, I'm going to tell you about a completely unsupported, very cool thing. So there's a white paper that you'll read if you want to go out and look at this. Written by some folks at Clout. If you've heard of Clout, they're like a social media tracking company. A lot of data. Some very cool statistics on how many hundreds of millions and billions of signals they're processing a day in that white paper. Denny Lee, who very well-known guy with Microsoft. He does a lot with analysis services. Now with big data, does a lot of work with some of the biggest, most challenging customer problems. So they've co-published this white paper. And they have a solution to be able to bring data directly out of Hive and process it directly into analysis services. Now, the story and the connectors for all of these things are continuing to evolve, right? So as HD Insight moves more and more towards general release, I'm sure that there's improvements to this process coming. But a lot of you want to go try it and experiment with it. And so I'm going to tell you three things. One, this is absolutely not supported by Microsoft. Do not call support. They will not answer any questions about it. Number two, if you have any questions about this, see number one, not supported. Number three, it does work. I've tested it, but there's one major limitation. You have to make sure the queries you run and your DSV queries and analysis services are select star from. If you start making complicated queries in your data source view, it's going to blow up. You're not going to get the results you want. So that's the important thing to keep in mind. The pattern is very simple. It's just a link server. That's really all we're doing. We're using a link server to push queries down through SQL Server down to Hive. Very, very straightforward. The pattern is very well outlined in the white paper. Because we're recording, I'm not going to go through all of it. But I will tell you there are some very cool things that you can go out, and I put the links in here for optimization for analysis services as well. So if you run into any data volume type issues, you can make sure that you apply some best practices there. Now, one of the things that you'll see out there as well, there are some ODBC drivers. And obviously the long-term direction is sort of we're trying to move away from ODBC and some of those types of things. Especially for big data and Hadoop, ODBC has some real challenges. So I wanted to call out a couple of those. So for now, the driver's out there, it functions. You can go grab it and pull some data in. Of course, it's beta like everything else, so you may run into a little, sharp edges here and there. But it is functional. That's, of course, also being worked on as part of the general release for HD Insight. But we get no results batching. So what does that mean? It's not going to queue the results back. So if we actually go in and hit an HDFS cluster and we pull back 1 billion rows, it's going to crash, right? We're never going to get it back. The other thing is it caches the entire result set. That's great when I need 100,000 rows from my database. That's not so great when I'm querying a Hive table that has 100 million rows in it across 16 nodes. That can be a challenge. I put it in there. Not good for big data. On the upside, we do get the output schema. So when it comes through, we get our column names and we get some metadata about the data types and we get some of those different types of things. For right then, we get it in Excel, we get it in whatever tool we're loading it into. As soon as we're done, we lose that again once the data goes back into Azure Blob Store. Okay? So there are definitely some challenges around ODBC. My suggestion is, unless you really need to use ODBC right now, leverage Data Explorer. So explore your data, work with it, refine it, and continue to improve what you've got there. Of course, the next option is Analysis Services Tabular for consumption. There we go. Of course, we're going to use the ODBC driver for that, so we may have a few little sharp edges until release time. The other important thing to remember is we're using SQL Server data tools to build tabular models and to deploy them. SSDT is a 32-bit application, and you're going to need to make sure you have the right version of the ODBC driver for development as 32-bit and the right version for production, which may be 64-bit or 32-bit, depending upon your environment. You want to make sure that the service account that's running your tabular instance, by the way, this one hung me up for about 3 days. It took 3 Microsoft people and me about 2 or 3 days to figure out why this wasn't working. Of course, on your default install of Tabular, it goes to a machine account, right? Which is fine for 80% of your local development. And I hadn't run into a problem with it before because it was a new machine. It's got to be running under your account, and your account has to have access to the tabular workspace server that you're actually working with. So if it's not your account, make sure it's a service account, and that'll work too as long as it has the appropriate amount of access. Both have to be the same account when you're playing around with this. Lastly, you're going to set up a user DSN to make sure that you can get this to connect. System DSN doesn't work right now. It's a sharp edge, right? Ultimately, will it work? Probably. But the user DSN is definitely the way to go. If you set it up and it's not a user DSN, when you go to the drop-down to pick your connection, it doesn't show up. So if you think you did everything right, and you get all the way to the end, and you go, I'm going to go get my data, and you click the drop-down and nothing's there, go check where you created the DSN. Okay? Also, we don't have direct query support. Not yet. I don't know where on the roadmap that is. I would assume it's coming, but I don't have any direct data on that. We want to try to use compression and partitioning to really improve that end-to-end loading performance. Again, the less data we move across the network, the better, obviously. So if we can move that data faster and more efficiently, we can load our tabular models a lot faster and better. Now, the other question we get is, where should we deploy that business intelligence? Should we deploy it maybe up in IaaS? or should we deploy it on-prem? How many of you have been to a Azure IaaS session this week? Seen any of that content? So there are some very, very cool patterns to be had up in IaaS because of the announcements that came at TechEd North America around clusters and machines now not being charged at all when they're powered off. So there's a lot of capability around, well, I get a lot of questions about where do I install which piece of the stack? Who can share a machine? Can I put analysis services and reporting services on the same server? And because most organizations don't go out and buy one new server for everything they're going to have to do, right? It fits in with an infrastructure plan. Well, part of that plan can be IaaS. And if you've got the servers in IaaS, I mean, the easy win is put your ETL on a server, on its own box, run it for the 3 or 4 hours you need it, and then shut it off. You can do it all programmatically through PowerShell. And when you start thinking about those types of things, it gives you a lot more flexibility to be able to pull that data from the cloud to the other side of the cloud, if you want to think about it that way, even within the same data centers, keep your cost very, very low, and be able to deliver a good portion of your BI from IaaS. There's a couple key things to make sure that you remember here. Just make sure that you really think through your network configuration. Once you create the machines, there's certain things you can't change, like subnets and where they're located, network segments and those types of things. Not the end of the world if you have to recreate it, but just takes a little bit of planning. There's a great white paper and some PowerShell scripts out there that will help you automate all of this creation. And I've got links to all those in the decks for you guys too if you want to play around with it and try it. There's also another session, and I apologize, I'm not sure who delivered it at this conference. In North America, a guy named Chuck Heinzelman delivered it. He's from the SQL Cat team. And it talks very much in depth about how to do BI in IaaS, where to put things, how to configure it. It was a very good session. So I would recommend checking out that recording, either from North America or from the European TechEd when you have time, if that's interesting for you. So the last thing I want to talk about, how many of you have heard of Parallel Data Warehouse? Good. How many of you have heard of Polybase? Okay, mostly just you guys. I thought you guys were the smarter side of the room, but I didn't want to tell them that. So Polybase is essentially a piece of functionality that's been added into Parallel Data Warehouse that gives us the ability to query Hadoop directly from the appliance and make it look just like another table on the PDW. It's very cool, it's very shiny, and it works really well. Usually, new features are only 2 of those. Usually, it either works really well from a performance perspective, but it's kind of hard to use because it's new and it hasn't been fully refined, or it's really flashy, but it maybe doesn't perform as well as we'd like, right? This actually does really well on both of those things. It allows us to scale unstructured and relational data together. So we can run Hadoop on the appliance, or we can run it off the appliance. We configure Polybase with the connectivity. And it allows us to do things like create SQL tables as select. We call it CTAS, create table as select, directly from Hadoop, which is very, very cool. So I can go in and grab a bunch of my files in a particular directory and say, create table as select. It's the same syntax that we use from Hive. So if you've created an external table in Hive, it's the same syntax. So if you're automating things and if your team is getting up to speed on writing that HQL code, they're going to be able to reuse that in a Parallel Data Warehouse environment. We can also create Hive tables directly from the PDW. So if we need to do some machine learning or other types of algorithms or additional processing, or if we need some PDW logging data for workflow check-ins or analysis, we can create that very easily with simple statements, same as going the other direction. The other thing that we can do, and this might be my favorite, how many of you know what InfiniBand is? How many of you know what a Ferrari is? So InfiniBand is basically the cable version of a Ferrari. If a Ferrari could still go 200 miles an hour and tow, let's say, 25,000 pounds. It's very, very fast, very, very high throughput. And it's what the PDW uses on the backplane to keep all of those individual nodes talking to each other as fast as they need to. Now, one of the big benefits, even without big data, is we can take an analysis services server and the rest of BI and co-locate it in the rack or locate it in a nearby rack in the data center and run InfiniBand. They give you extra ports in the switch. Depending on the size of the unit you buy, you can run the InfiniBand directly over and connect it to the rest of your BI environment. I've seen analysis services environments that were taking 6, 7, 8 hours to process come down to 37 minutes, 38 minutes. What's the slowest thing in your infrastructure? Your storage, always, right? What we're doing is removing a lot of that backlog. So the storage is distributed on a PDW, so we get the distributed, parallelized processing to bring the storage together. InfiniBand gives us the backplane horsepower to be able to move that data very, very quickly. Now, that's great for existing BI. How do we use it for big data? The exact same way. Polybase gives us the ability to take our Hadoop cluster that might be sitting over here 2 racks over and wire it in through InfiniBand, and we get very fast data movement between our environments. So if every day we're going to bring in 5 more terabytes from our big data system that we've processed down, that's no longer a conversation of, well, will it finish overnight? It'll be more of, how long will it take? Let's run some tests. Let's be agile, right? And I think that's the biggest thing I want to encourage you to do when you look at your big data environment, is don't think about it in terms of maps and reducers and Hive and Pig. Think about it in terms of, what are you trying to accomplish? What would you like to do today that your existing system may not let you do? And I would attempt to find a pattern to solve that in the big data ecosystem, because I have a feeling there is a pattern out there that will help you in many cases. And if you have a particular question, don't hesitate to email me. If I don't know the answer, I'll put you in touch with the folks at Microsoft who can absolutely help you just talk through it and brainstorm. There's a lot of really, really great, talented people that are focused in this particular area. So I've got some next steps for you, since you guys are all very excited about all this now. All week you've been hearing about big data and Data Explorer and all these things. So I have a couple slides where you can go out and sign up for the HD Insight Developer Preview. You can go get Data Explorer, GeoFlow. How many of you saw GeoFlow this week? I know they had it in the keynote, I'm sure. If you guys really want to play with GeoFlow, they have that 80-inch touchscreen down by the booth at Microsoft. You can either play with GeoFlow or you can play Angry Birds. They have both of those on there. I like Angry Birds, but I'm just saying. You want to make sure that you get signed up for a Windows Azure account. It won't cost you anything until you begin to really deploy anything sizable. So it's a great way to just get started in that technology. I've also added some big data resources here for you. These are different bloggers, people on Twitter, different vendor sites, all of that type of stuff that might be very interesting for you as well. Some additional case studies and white papers are in there. And again, I'll make sure that this deck gets updated out into the portal so you guys can have all of the speaker notes and little links and all the additional tiny little details that, of course, we don't have time to go through in a 75-minute session. So thank you guys very much for your attention. I'll be here. I'm happy to answer any questions now, or I'll stay just a couple minutes afterward and be up here to answer any questions that you have. Thank you. The last thing I'll say before you all run out the door, please, I would encourage you to fill out an evaluation for the session. Let us know what you thought. The speakers all really like reading the evals. So the scores, we say the scores are for Microsoft, the comments are for us. So we read all the comments. So please feel free to fill one of those out. I'd really appreciate it. Thank you, guys. Have a great day.